Okay, so let's see. Um, we're gonna go back to the syllabus, see where we're at. 1 April. So we already did a little bit on data structures. I'm going to kind of review that because that is actually not super simple. And then we'll go, and then if we can, we'll try to start attacking filling arrays from data files because that's what's going to be used in part 7. Um, yeah, Keith, I can't hear you on speaker. Um, and then so the next so part program 7, if you look at it later on, what it involves is oh, so some people aren't hearing me. Um, is anyone else having problems hearing me? Keith, maybe check your volume and check your microphone settings. Not your microphone settings, but your speaker settings. And you might try a reload. So some people are still not hearing me, but some are. Okay, let's make sure we got that. Okay, let me see if I can corral them from the other room. So we're gonna do something kind of meta here. I'm going to go to I'm going to see if I can, from within WebEx, go to Collaborate Ultra and then get people to go to WebEx. So hopefully this is not crossing the streams and it causes the entire universe to collapse in on of itself.
Clean, 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 clean.
Okay, so hopefully that brings everyone to WebEx. Okay, let me see if I can do a poll. So I'm just testing my sound. If you can, reply yes or no on that poll that I just sent out. And let's see. So let me know if you can hear my sound. And I'm going to reshare just to make sure that my screen is showing up. So we'll get started here in a second. Let me just trying to manipulate some things on the screen, make sure it's all working. Okay, so hopefully everyone can hear me now. Um, and so as I was saying, program 7 is going to basically be reading a data file and then processing the data in that file. So today I'm going to go back through data structures. Well, I know we already did it because you need it for that one program for rock paper scissors, but it'll be useful for this data file stuff. And then I'm going to continue on. If we have time, I'll try to get into filling arrays from a data file. So let's see. So going to learning modules and chapter 6, data structures. And let me see if I can find that. Okay, so today we're going to look at data structures again. And just to review, basically what the data structure was really a way to take, basically a group of elements and put them in one, bundle so that you can access them all under one variable name. So unlike, yes, this will be available for download. So unlike other, um, if so with an array or with a vector, that's basically a sequence where everything is of the same type. With a struct, basically, it's one bundle where you have, struct, the name of your struct, and then the elements that you want in the struct. Now, this is not really a variable definition. This is a type definition. And after you define this struct, then you will define a variable which will be of this type that you've just created here. So it's a little bit, so this makes it a little kind of harder to understand. Think of the struct as a pattern that will be applied to, or think of it as kind of a, actually the word structure is really good. It's a structure for how we want to store some data for a particular element. So, when we did the books struct, we say, well, what do we want to know about a book? Well, we want to know its title, its author, its subject, and its ID. So in order to store that, we're going to create this struct, which says that if you're a book, you will have these 4 elements. So, we could say, we could make these separate variables, but then if we wanted to store information for multiple books, you'd have to have, a variable for book 1 title, then for book 2 title, then book 3 title, and you have to declare all those variables. This allows us to make a structure for it and just declare a single variable for book 1, book 2, book 3, and then when you put book 1.title or book 1.author or book 1.subject, you would get all these elements in it. And it helps us to better implement the dry principle. Someone tell me what dry stands for. Can you all hear me? Don't repeat yourself. Yes. Unless you're an instructor, in which case you constantly repeat yourself. But as a programmer, we don't like repeating ourselves. And so this allows us to kind of say, hey, I'm going to have to store these things for multiple items, so I'm going to create this struct. Oh. And let me get Socrative up and running. Yeah, we did this before. I'm just kind of reviewing it. I just want to make sure people get this concept. One of the reasons is because it's going to be really useful to understand this really well before you go into the next semester and understand classes. Because if you understand structs, you are about 50% of the way there to understanding classes. So I'm going to hit this a second time. We've got this book struct, and after we declare a struct, you can actually right away use it to declare some variables. So here we declared this struct called books, and notice we're using books, the book struct, to declare two books, book 1 and a book 2. And what that means is that book 1.title, book 1.author, and book 1.subject is in existence now. and then and yeah, actually, I've got a lot of these things. I have I've pre-recorded videos. Those are usually much more concise than like these classroom videos, because I'm just doing a present. I'm just doing a demo. And then book two will also have a title, author, and subject. So basically, we define this structure and then we apply it 2 times, and we don't have to declare like, if we didn't have this, we would have to declare maybe 8 variables to do the same thing here. Now we only have to declare 2. So it makes you much more efficient. You can also do it all online, but we're going to find that we tend to not use this format. What we tend to do is we declare books in the .h file, and then we use it, in either functions or in our main function. And so you probably won't do this right away. Do it this way. And then we can use, we went over how we can use the dot operator to get access to the individual elements of our book. So often we do it this way. We declare our structure in the .h file, and then we use it other places. So here in main, we're declaring 2 books, and then we're setting the values for a book using the dot operator. And so you can think of it as, hey, this is like a variable which has a bunch of subparts that I can access with the dot operator. Does that kind of make sense? Yeah, and one of the ways you can think of this as a book, something that's a book has an author, has a title, has a subject, has a book ID. So the dot operator is kind of it's kind of like has a relationship is what we're developing here. And then you say that book 1 is a book, therefore it has a title, it has an author, it has a subject, it has an ID. Book 2 is also a books, so it also has a title, has an author, has a subject, has a book ID. This is called the has a relationship and the is a relationship. So if you are a books, then you have those things. Does that concept kind of make sense? Then you would probably have to, so James asked, what if the book has a character other than a number? If that's the case, then you would probably not declare the book ID as integer. You would define it as a string. And, a big part of building your structure is saying, how do I need to store this information? And then here we are, basically here we were assigning into those, into those attributes, those variable elements of the struct. And then here we're pulling them out and using them. So very much like a variable, in many ways you can say book 1 title, dot title is the whole variable name for the title. And so, you couldn't just say title, it'd say title of what? You have to provide the book 1 dot in front of it or the book 2 dot in front of it in order to use it. And did we already do these questions? Okay. I'm going to flip through them then. Actually, just for my own edification, I'll do these kind of quickly, just to make sure that we've got them. And so someone, and whoever gets it first, just need a few people to confirm to me that you have it. So I'll just, we'll just do these for a couple minutes. So write this. How would we define a structure that stores information for a student with an int for student ID, a string for first name, and a string for last name? Just for practice, go ahead and put that back in. Yeah, well, I can kind of do that. Does that work? Of course, then you can't type into that one. That probably adds more confusion, actually. Yeah, so I think people are generally getting it. I'll just review it real quick here. Or not real quick, but yeah, we use the keyword struct. We put in student ID, and then we'll play around with those in a second. And then try this one. Declare two variable types, student one and student two, using your student struct. Yeah, maybe I'll go more in a presentation mode. Because you're kind of flipping back and forth between applications, and then and it's a little bit tougher in this format. I just need to build my own presentation application. It's one thing that will happen when you become a programmer. You want to rewrite everyone's software. But you won't have time. Actually, I was thinking about doing that as a project, maybe over the summer, getting some students together, and we make a kind of a combination of a website, a phone app, and a Windows app that all kind of integrates together through the web. Kind of what we'll do probably this is really something where you kind of need C# at the time, but we can kind of drag people through stuff maybe a little bit. And my 2284 class, if you've completed that, then this will be right at that level. But I might do this maybe I'll do this like a summer thing where we build this kind of combined app that really works through getting through everything that we do, so that so that you have like a real portfolio item that shows you can code everything. It won't be a formal class; it'll be more like a hackerspace thing, but it might be kind of fun to do. Okay, let's see. So let me just do this. I think it'll be more efficient. I'm going to create I'm just going to go into more display mode. Oh, get back here. Do I want a console app? Yes. Oh wait, no, we're C++. I want a C++ console app. I need to make a spinny thing that's off to the side here so people can tell if it's So while that's spinning up, I'll go ahead and talk. So we'll play around with so I'm just going to, and this isn't a formal demo. I'm just going to kind of play around with the structs just to kind of review. I think pretty much everyone's probably already done this, but just as a review, we will. I'll show. So this is, you know, you can declare your struct actually. You know, even in here, kind of. So you could say struct. Let's pick something else. There's books. We did students. Um, let's see. What would be a good collection type thing to put? Let's see. Movies, maybe. So I'm going to make my struct for movies, and actually, I kind of think I'm gonna do it this way. I kind of think it's good to make it singular because this is really defining one one film. So string title. And then we might have a string studio, and then string date. Actually, I think I want these to be lowercase. And once we do that, you could declare your variables here, like film1, comma film2. Of course, these would now be global variables, and so you know, then we could say film1 dot title is equal to a great movie. And then film2 dot, you know, film1 dot studio equals some studio somewhere. And then film1 dot date, I need to fix that, of course, equals today. And then you could go in and say film2 dot title is equal to another great film, and then so now you've got you know, your film. Does that kind of make sense what's going on here? This really is just giving me a structure, and this is declaring the two variables directly. I don't like this because these are global variables. So rather than that, what I recommend is declaring your structure, and then declaring your variables inside of main. Does that make sense why that would be better? Yeah. So you do that here. Now, once you have that, it actually makes sense at this point then to add, you know, a header file. Yeah, they become local, and we want to, and we like making our variables local. Why is it better to have local variables? Oh, James asks, how many elements can you add to, say, the struct film? Actually, the struct film really only stores information for one object or element, this film one. So you can only have, one title, one studio, and one date for this one film. So let me get my if and f. So if it makes sense then to put the struct definition in your .h. Yeah, basically what's happening is it's like you're making, film one is our variable. This is a structure. It's not a variable. It's just this type that we create. And we declare film one of type film. It'd be kind of like if I declared a number, right, into num. What's the type of num? What's the type of film one? And you defined this, right? So that's why we say a struct is a user-defined type. Does that make sense? And in this user-defined type, you can define what type of elements it has, and you might call these attributes. There's a lot of words that get used for these types of things. So a film has 3 attributes: a title, a studio, and a date. And therefore, we are defining this user-defined type film, which has 3 attributes: a title, a studio, and a date. And therefore, we use the dot operator to get access to the attributes. Does that make sense? Okay, if that makes sense, you are about 50% of the way of understanding how classes are made. You're going to learn that next semester, but I wanted to kind of review that because it will help you out. Yes, and we call this the dot operator. It's the smallest operator in programming and yet one of the most powerful ones there are. And the reason why this is powerful is it allows us to to package a lot of information into one variable. Now let me ask you this: if I wanted to store make a collection of integers, I would include vector, right? And then I could maybe declare a vector of int called numbers. Does that make sense? And you would do numbers dot pushback, maybe 5. And then numbers dot pushback, maybe 7, etc. This is the identifier for my vector. This is the type, and then in these braces here, I put what kind of thing is this? Int doubles data type. It's a data type, right? Excellent. So this is a type. Right? What's that? It's a structure. It's also a data type, right? It's also a data type, and that's a data type. Could I do this? Yep. So now I have a collection of films. And instead of doing this, could I say, I create film 1, and then could I say films dot pushback film 1? So I've created a film, and then I've pushed it back onto my vector. And then I've created a second film and pushed it back onto my vector. Yes. So now let's see if I can see out films. And then films is, vector, so I can get access to the first one this way. And then I put dot, and you notice that I have dot title. Can everyone see? So I can't do that dot title because that's a collection, right? And that gives me an error. I have to index out, I have to index out the one I want. Once I have this, that refers to the film. Then I can get to the element. So remember how you were doing parallel with the planets program? You're doing parallel vectors and then referencing back and forth. This kind of makes that a little easier. So that's kind of the way structures are often used. And then I'm going to run this and we'll just see that that kind of works. Why are you screaming at me? Oh. Probably need to have some includes in here. And so we get, and we can see that, yes, we can index out whatever we want. off of the using that that struct and that vector. You can also use that format of it. Oh. Films. And that works too. And, you know, if you're doing those things where you need to compare, have several pieces of information that are parallel, you know, once you have the index, you can grab whatever you want, you know, and it will deliver the thing you want, you know, very nicely. So that's how we can use a struct. So we're going to hold on to that information, and I'm going to now discuss how we read a file which has data. So let me pull up that presentation. So now we're going to look at different ways of reading files that have data in them. And I don't know if you all have seen these things before. They're called files. They're made with this stuff called papyrus, and they're made, and you put little sheets of things that were called paper in them, and the paper we would write on them with these pigments that were dissolved in solvents in order to record information. And so we think, so really data files today are really just you know, a electronic representation of that. And so in real programs, actually all programs are real programs, but in programs often data is stored in data files or obtained from a database. You're going to learn how to work with a database in the next semester's classes after C++1, and we're just going to restrict ourselves to working with files. Let me ask a question. Well, I think we already discussed this, right? Normally, your code in your program and your variables is stored in what kind of memory? RAM. And where are files stored? On the hard drive. So for us to persist information, we often need to store it on the hard drive. And so that's why we use files. We already did, I think, both opening and writing, opening files and reading from them, and writing to files. Am I correct? Yep. So this is really going to be about, okay, now that we know how to open and save, write to files, more about how you would store information on there and read the information off of it in, for example, a table. And so we already looked at the IF stream and the OF stream classes, I believe. But let's say that we wanted to read numbers. So here we have an example where we have this phone bills program and this text, or a text file, and in this text file, it's, you know, it's written with C++ phone company, customer Bjarne Strustrup, January to December 2007. I don't know who broke into Bjarne's home and stole his phone bills, but apparently that was done to write this this example. And you can see here we have a bunch of values. What would be the best data type to store these values? A real number, and what real number formats do we have in C++? Float or double. They're pretty low precision, so probably a float could be the most efficient way, but either one of those would work. They chose floats because they're pretty small precision numbers. And they made an array of 12 phone bills, and then we have sum, average, and max. So what they want to do with this program is read this phone bill file, figure out what the sum of all these numbers are, figure out what the average of all these numbers are, and figure out which one is the highest. And they're going to, when they get done, what they want to do is write this phone bill to another file and put all that information. So it says, Bjarne Stroustrup, January, December 2007, phone bill summary for C++ phone company. Total yearly phone cost is $570.14. That's the sum of all these numbers. The average monthly bill is $47.51, so that's the average, and the max is $52.65. This is pretty similar to what you're going to be doing with program 7. So let's look at how this one was done. So they use a define statement to define file in and file out. This is a really good practice. As a programmer, anyone know what the term magic number means in programming? So a magic number is you're reading your code and suddenly there's just some number, like an arbitrary number, like 12 inserted into some variable, and you don't know what 12 is. It's far better than, rather than putting 12 in there, to actually define use a define statement to define number of bills per month at the within your program, and make a constant out of it, and then put that define statement there, so that rather than seeing 12 there, they see something like number of bills per month, and that way it makes your code much more readable. So it's a really good habit to get into, is if you're about to just write a literal value into something in your code, to instead define use a define statement or a constant to do that. It also makes your code easier to update. So for example, let's say that someone decided that we're not going to have 12 months per year, we're going to have 13 months per year. And some law was passed, and then we all had to comply with that. Well, you could just change that constant. It would change it throughout your whole program. I like giving realistic examples. Okay, so here we have, and then so those are defined. Then we have these functions. We're going to have a read bill data, and notice we're passing in an array of floating points bills. Notice in the function definition, when we pass in a parameter, we don't put the number of elements here. We just put in hey, this is going to be an array. And then how are we passing in customer, company, and year? What does this symbol mean in this context? Not address of really here. Here we're saying this is a reference, yes. And so we are going to get addresses, and we are going to get this will be passed, as a reference to the pointer. But remember, when we have the ampersand in the function prototype or the function definition, that's really saying, hey, I want this passed in as a reference. And then and why are we defining this with defining these as references rather than just passing in the values? Are we really passing these values in, or are we bringing them out? Right. So whenever you see like a pointer or a reference in a prototype, you can say, oh, this thing is actually bringing these things out of that function, and we're not putting them in, we're bringing them out. So obviously with real build data, the purpose of that program is going to be open the file, read the values, and then pull those strings out of the file. And what those are going to correspond to is C++ phone company, customer Bjarne Stroustrup, January, December 2007. So it's these first three. It's these first three lines that we're pulling from, and this function is going to pull them out of the file and return them to main through these three reference variables as strings. Does that make sense? And then we have calc bill total and average. Again, what this one, notice this one is going to calculate the total and the average. They kind of did something weird here. They're going to return the sum as a reference, but how's the average coming out of this? Well, you can see calc bill total average has a return type. So what they've done here is they're going to return the sum, the total through this variable, our sum, and then they're going to pass that through this reference variable, but the average is going to be the return of this method. I don't like this very much. I think this is a little bit convoluted. I would have said if you're going to be return everything out through through a reference, probably return both model of reference and make this void, but that would work. And then find max is going to find the maximum value in the bills array, and then return them as the return value for this value, and then we're going to pass in the sum, the average, and max, and all this information, and that's going to write it to a summary file. Why does this write method not have references here? Why is it just passing that stuff in? Well, if you think about it, the write summary is actually, we're passing in the values, it's going to write it to a file. It's not actually, the write summary file is not getting anything and bringing it back out of the function. It's taking everything into the function and throwing it to a file. So if one of the ways you can just, from looking at function prototypes, you can figure out what's going on is whenever you see a lot of references or pointers, okay, this is really producing information and returning it back to the calling function. When you see a lot of passing by value like this, oh, that one's just using the information, but it's not actually producing anything. In fact, the only thing this thing produces is a Boolean, which is clearly there to say whether or not it successfully wrote the file. So at this stage, you could probably figure out this code just by looking at the function prototypes. You can kind of figure out how it's operating, and if you understand kind of those principles. So let's look at the actual implementation a little bit. In main, they define an IF, or actually, let's see. Yeah, this is the code that's in the read file. It opens an IF stream object to do the reading, opens file in. Notice that it's using the constant defined, which is defined up here. And you see the elegance of this is it's actually easier to kind of see what's going on, and I don't have to type the same thing twice, so I don't violate the dry principle. And then, while not bill input, it will read through, or if not bill input, we have a guard here, but it basically says, hey, if we can't open this file, then we're just going to say we can't open it and return false. And then it'll go through and read. So once it has it, it's going to, that program is going to loop through and read it. We don't see that code here, but we'll experiment with that concept here in a second. And then in the main, what you're going to do is once you have the array with the bills in it, you're going to pass that to the get. Or actually, I'm sorry. So we open the file, we check to make sure the file is open, and then after that, the first three lines we want to read are these first three lines here: C++ phone company, customer Bjarne Stroustrup, and then the date. And so we do three get lines. And rather than reading from cin, we're going to read from the file. Bill input is the file. And then we're going to pass into those reference variables that are in that function these three lines here. And then now we're down here in these numbers. And to read those numbers in, what we're going to do is we're going to use a for loop. There's 12 elements here, so we're going to read 12. We're going to do this loop 12 times, and each time we're going to read into the bills array, and we're going to use the I index to put each one into each element. Does that make sense? And then we close our file and return true, because at that point we were able to read the file. So that's the how we read the files. Now the write summary file function, basically it opens out an OFStream object, and basically this is doing the same. We have the same. And this is called a guard. When you in your functions, when you have a if statement that checks for some condition, and if it fails a condition, it returns it returns before it gets to the rest of the program. You could do this with an if else, but this guard structure kind of, if you have a lot of guards, it's kind of an elegant way of doing it, because you just return for, if any of those fail, they do a return and they stop executing the rest of the program. And so this checks to make sure that the file again is open. And then if it isn't, it returns false. And then down here, if we successfully opened it, we're just going to write everything we want. And so it says, bill output customer. We brought in a customer, so we output that. Then the year, and then we output, the who the bill summary is for, what the company name is, and then we output. We set the precision, iOS fix, and put $signs in front of everything to put the sum, the average, and the max out. And then close. So that's really just couts type of stuff, if you think about it. But instead of outputting to cout, you're outputting to the bill output. Does that make sense? So all that's really left then to understand is, and that's what that output will look like. So is maybe how to do the numeric functions of how you average and all that type of stuff. So I think we're going to experiment. I'm going to make a text file, I think. Actually, let's take a break. We've been going for a little bit. Let's take a 10-minute break. And then if you want, open up, let's see, do I have a demo for this? Maybe I have a demo. One. Did I have it in kind of backwards orientation? Looks like it's in data structure for some reason. That doesn't look like a Redditor demo. Presentation, book structure, example code read. I think that's just a program. So I'm going to probably just put together a demonstration when we get back. So go ahead and take a break. We'll come back at the 40 after and have Visual Studio open for playing around with this stuff, so reading the data file. So see everyone in about 10 minutes.